Alright guys, welcome to the 1.6 notes. Okay, so I totally blew it the first time I recorded this doing the first question, so I'm just redoing it again, and there'll probably be like a nice awkward transition. Anyway, let's dive right into this. So, whenever we're plotting piecewise functions, the first thing that we're going to do is we're going to plug in the boundary points to each of these. Okay, so we're plugging in all these boundary points into each of these equations respectively. So then when we do this, we're going to have negative 3 halves times negative 2 minus 1. That's going to give us positive 3 minus 1, which would give us 2. So now we have this point, negative 2, 2. So then let's plot that. Negative 2 up 2. It's an open circle because it's just less than. So we open circle right here. After that, we're going to plug in the next thing. So it's going to be 2 times negative 2. Minus 1, which gives us negative 4 minus 1, which gives us negative 5. So then that would be, what is that, negative 2 we plugged in? We got out negative 5, so negative 2, 1, 2, 3, 4, 5. That's a closed circle. After that, we're going to plug in 1, so that's 2 times 1 minus 1. So that's 2 minus 1, which gives us 1. So that point is 1, comma 1. Plot that point. And then the last point we have is when x is greater than 1, we have negative 7. So that would tell us 1, negative 7. So we go negative 7, and then that's an open circle. Okay, and we can actually plot that, right? It's saying it's going to stay negative 7 as long as we're going to the right of 1. So we have that horizontal line. The middle section is nice because it has 2 endpoints, so we just connect those. And then the last section, we have to follow the slope. It's saying negative 3 halves. So we need to go negative 2 because we have to go to the left, so negative 2, and then up 3. Puts us right here, and then we can graph it. Okay, so nothing crazier than what we did yesterday. The domain, just like yesterday, is all real numbers. The range is where it gets a little bit tricky. Okay, so like yesterday, I said start at the lowest value. The lowest value in this case is negative 7. Negative 7 is included. Okay, so we would put a bracket negative 7 because although it's not included at this singular spot, all of these values past that point are all included. So we would put negative 7. From there I said follow the graph up. Well, if we follow this graph up, there's a huge gap, right? So there's all of this section right here where there's no y values. So what we have to do is we're now going to close that negative 7. So close it and put a union sign. Union is telling us that we're jumping. We're jumping to this value, negative 5. So we can bracket negative 5 because it's a closed circle. And then we continue following the graph up. When we follow it up, it stops at 1. And then we look to see if we jump again. And you can see right here, we skipped a section of y value. So we're going to need to put another jump. So that went to positive 1. We would close the bracket, and we would put a union. Okay. The value that it jumps to is positive 2. Right here is a positive 2, and then we're following that up, and it's going to positive infinity. Okay, so the range is weird. Look at all those different pieces and parts of the range, and that's because we made jumps. So as you're doing this today, there's going to be some jumps in the piecewise functions. So the next one, number 2 here. Number 2 says we have the negative absolute value of x plus 3 plus 5 if x is less than or equal to negative 1. So then we plug that in, right? We got to plug in that boundary point. So we have negative 1 plus 3 plus 5. Okay. But when we do that math, we have negative absolute value of 2 plus 5. So that's negative 2 plus 5. So then that's 3. So we have negative 1 comma 3. That's a point. So negative 1. Positive 3, 1, 2, 3, closed circle because it's equal to. Okay. From here, we got to make sure, do we have the vertex? So vertex of this graph is going to be negative 3, comma 5. So negative 1, 2, 3, 1, 2, 3, 4, 5. Because we're graphing absolute value, it's important to have that. And then to finish graphing this absolute value, we follow the slope. So the slope is down 1, right 1, down 1, right 1. So that's that point. The other way is down 1, left 1, down 1, left 1. We know it's down because it's negative. So on the left side here, we're going to continue at that slope. So down one to the left one will look like this. Maybe if I could just draw it. Whoop. Like that. And then in the other direction, we're just going to stop at that boundary point that we found. For the next half of this, it says x is greater than -1, so 2/3 times -1 plus 2. That gives us -2/3 plus 2. If we wanted to do this, we can multiply by 3 over 3, so -2/3 plus 6/3. That's going to be equal to 4/3 positive, so that's 1 1/3. So that's -1 comma 4/3 is our point here. So then we go -1, and then 1 1/3 would be right here. And then to follow that slope is +2/3. Okay, so that means we're going to go to the right 2, 1, 2, and then up 3, 1, 2, 3, puts us right here. And then we just graph that. So it should look something like this. All right, domain, right? We're going to the right forever. We're going to the left forever. There is a point right here. It's right there. All real numbers, domain. Range in this one, right? It's going up forever here. And then we start at this top section, we go down forever here. So it's going up forever, and it's going down forever, and all of this middle section is also counted. So this is a special range where we get all real numbers. Okay, so that's the special range involving that question. All right, so one more piecewise function to look at today. The last piecewise function to look at is this one. Remember, whenever we're doing this, we look at the boundary points first. So the boundary points are at 1, 2, 3. So when x is less than 3, we have an x is equal to 3. And then we have an x is greater than 3. So when x is equal to 3, that's probably our easiest one. We have just 1. Okay. When x is less than 3, what do we have? So let's go up here. We find the slope, up 1, 1, 2, 3 to the left. So that's -3, +1. So the rise is 1. The run is -3, so -1/3 x. And then the y-intercept is 1, 2, 3, 4, so +4. And then down here at the bottom, we have a slope of 1, 2, 3 negative, 1, 2 to the right, so -2, or -3, +2. So then -3 halves x is going to be at the bottom. And then if we follow that slope, 1, 2, 3, 1, 2, put us here, 1, 2, 3, 1, 2. So we don't quite perfectly go through an exact value. So what we're going to have to do is use a point on the graph to find the b. Okay, we actually know a point, right? So this is a point on that line, and it's +3, -2. So then what we do is we plug in -2 equals the -3 halves, and then we have +3 plus b, and now we're solving for b. So -2 is equal to -9 halves plus b, and so we're going to add those 9 halves over. So you can think of it as 4.5 to both sides, right? And then 4.5 minus 2, what is that? That's going to be 2.5 is equal to b. So then 1, 2.5. That does look like it makes sense. So then we would say plus 2.5, or you could say 5 halves, whichever you prefer. All right, now let's look at figuring out what the domain is. So domain does jump around a little bit, but all of the x values are included here. And then range might be a little tricky here. So we're coming from -infinity, and then we're coming up to this point -2. So we would say -infinity to -2, not included. And then we have this jump right here. So we would say union, because we have a jump. Whenever there's a jump, it's a union. +1 is what goes in there next, and then you can see we jump again. So we need another union. And then this is from 3 with a parentheses because it's not included, all the way up to positive infinity because it's going up forever. Okay, so that is a little bit of a tricky range because there's 2 jumps that we have to include. Just remember, whenever the graph jumps, we're just going to use union signs. Okay, so that one's tricky for a couple reasons, right? We had to find the b value, and then the range is a lot longer than something that we're used to. Okay, so those are 3 little piecewise functions that are definitely a little bit harder. If you have questions on them, I'll be happy to talk about them when you guys get back to class. Okay, so keep those questions circled and definitely ask them next time I see you. All right, last question here. So this is a question not really necessarily working with piecewise functions, but let's take a look at what it is asking about. It says a submarine descends to a height of 100 meters. Okay, should probably say depth, right? A depth of 100 meters. The pressure P in kilopascals on the submarine's sidewalls is given by this equation. So P of H is equal to 101 plus 9.69 H, where H is the depth in meters. Okay. What is a reasonable domain and range of this function? Give answers in interval notation. Okay, so the domain that we're talking about is all of the h's that we're going to plug in, right? So we always want to look at domain first because it's talking about the value that we're plugging in. So we're talking depth for h. So it says the lowest that it descends is 100 meters, okay, 100 meters deep. So I would say in this case, 100 is going to be the upper bound, okay, because 100 is the biggest number that we would plug in for h. So we can say 100 is the upper bound. The lower bound in this case is, well, how least can the submarine dive, right? Well, the submarine could be on the surface of the water. The surface of the water has a depth of 0, right? So that's going to be the lowest possible value we plug in. In order to find the range, we're going to plug in the lowest x value and the highest x value, and then that should give out what our range is going to be. So if we plug in 0 into h, we would get 101 plus 0. Okay, so that's going to give us just 101 for a lower bound. For an upper bound, we're going to plug in 100. So 101 plus 9.69 times 100. That's going to be 101 plus 2 decimal spots, so 969. So that equals 1,070. 1,070. So then our highest in the range is going to be 1,070. Okay, so literally to find the range, we plugged in lower bound, plugged in upper bound, and then that popped out lower bound and upper bound. Okay, so last question says, what is the pressure on the submarine at a depth of 74 meters? Well, in order to do that, we just say P of 74. Okay, and we plug it in. 101 plus 9.69 times 74. I'm going to have to look up what that is. 9.69 times 74, I don't remember. 9.69 times 74. So that's 101 plus 717.06. So that's going to be 818.06. So that's 818.06 kPa. Okay, and that would be our final answer for that question. Okay, so little word problem practice for all of us, because there could be a question like this on the test, so it's always good to practice those types of questions. Okay, as always, if you have questions, feel free to email me, Canvas, message me, whatever you guys want to. But also, we just finished up Unit 1. Okay, this was the very last thing in Unit 1. So start the Unit 1 review tonight and come with questions on the next time I see you. All right, have a great rest of your day.